so here's part 2. All right, so again, guess and test, obviously, guessing here and testing isn't going to work, right? Like, I think there's 20, I think there's 10, that's not going to work. A lot of times kids will do on this is they'll draw pictures, okay? One of the big things here is sometimes children will be like, well, is a 50-cent coin change for itself, right? And again, this is where math teachers historically, I counted it wrong. It was supposed to be 10 or 9, and you put, if a kid counts that as change for itself, like 50 cents, it's fine. The thing is, the goal here is problem solving, thinking. So a lot of times kids will just draw. So they'll go like, oh, quarter, and they'll physically draw circles with like a Q in it or 25 cents aren't. Like they'll literally make quarters. And then they might do, they might jump to all of the same coins. So that's pretty common. When I look at work, it's like I see 2 quarters, and then that person might draw 5 circles and put a D in all of them for dimes. And then that same person might draw 10 circles, like little pieces of coins, and then put N on all of them, or 5 cents or something for nickels. So sometimes kids will do all of each. And then at this point, sometimes they'll just do random stuff. They'll do like, ooh, I can do a quarter, 2 dimes, and a nickel. Oh, I can do this. And then the problem is they come up with an answer of 7, or they come up with an answer of 6 or 5 or whatever. And then it's like, okay, well, then they kind of lose track because it's not super organized, okay? So an organized list is a pretty good idea. So if I make a chart that has Q at the top for quarters, and then dimes, and then nickels, and then we'll do pennies. So maybe we can do what we started out with, all quarters, which would be 2, and then zeros, or just leave them blank for the rest of the chart. And then if I put 0 for quarters, and maybe, what do we have, 5 dimes, and then again, you can put zeros for nickels and pennies if you want. And then the last one we did earlier was all nickels. So 0, 0, and that was what, 10 nickels, and so forth. All right, so now we can try to find the chart and make it a little bit more, I guess, organized maybe than what just randomly doing. So I could go back to my quarter and be like, well, what if I have 1 quarter? What's the most number of dimes I could have, which was 2. And then, oh, and Julie needs to read. It says, without using pennies. Well, let's get rid of the pennies column. Sorry about that. That would create a lot more options. All right, so 1 quarter, 2 dimes, and so that's what, $1.20, so I would need what, 1 nickel. So then what else could I do? Well, I could do a quarter with 1 dime. So then that's at what? 1 quarter and a dime puts me at what? 35 cents. So I would be 3 here, because when I trade in one of those dimes, I would need 3 nickels. So 113. All right, so then what? Well, what if I have 1 quarter and I have 0 dimes? So I don't have any dimes. Then these would all be nickels. So 1, 0, and then I would have 5. And that would get me to my 25 cents plus 25 is 50 cents. All right, and then I'm just going to double check, like, is there any other way to use 1 quarter? And I don't think so. So I'm going to start with 0 quarters, and I'm going to do all dimes, which is 50. We've already done all of them. So I'm going to go down to 4. So that would mean 2 nickels, so 0, 4, 2. And 0, and again, if I do 4 again, that's going to be the same number of nickels. So I'm going to go down to 3 dimes, which is 30 cents, right? So I'd need 20 cents. So that would be, what, 4. And again, if I take a dime away, I gain 2 nickels. So I'd have 0, 3, 4 on that column. So now I'm going to go 0, 2. So that's going to go up to 6. And again, if you don't trust your math, 6 times 5 is 30 cents. And then you'd have 40 and 50s. That's good. And then 0, 1. So again, that would go up to 8. And then if I had 0, 0, that would be all of the same. All right. So now, let's see, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, and I can't have 0, 0 because, again, that would be all nickels. So it looks like there's 10 ways. If you had 11, you probably counted a 50-cent piece as a method, which is totally fine. There's nothing wrong with that. All right, but again, using an organized chart to help you keep track, or organized lists instead of just randomly trying to come up ways, will help you not miss something. So a lot of times kids like to list out, but then they miss ways. So trying to use an organized chart is great. And again, you just want kids to do this. You're not going to lecture and say, oh, do it this way. And that's why in class I like people to share their methods, because then other people can be like, oh, I did it this way. I didn't even think about doing it your way. All right, let's look at the next one. a lot of people sub in numbers here. That's pretty common. So when I look at work, a lot of times people will be like, well, I just subbed in n equals 2. And I just wanted to see what each equals. So 2 times 2 is 4. Sub 2 in, you get 5 because 2 times 2 is 4 plus 1. The next one is 2 parentheses n plus 1. So 2 n plus 1, 2 plus 1 is 3, and that's a 6. Sub in 2n to 2n minus 1. 2 times 2 is 4, minus 1 is 3. And then 2 parentheses n minus 1. Sub that in, 2 minus 1 is what? 1, and you get 2. And so what they do is they organize these numbers, and then they can organize the other ones. So we want to go from least. So they look at their smallest number, 2 parentheses n minus 1. Cross it off. The next one was 2n minus 1, because that one equaled 3. Then they go to their 4, which is 2n. Then they go to their 5, which is 2n plus 1. And then they go to their top one, 2 parentheses n plus 1. And that works out great. Sometimes people just think of this as algebra. So if you think of a number line, I'm going to draw a big number line. And instead of putting 0 in the middle, I'm going to put 2n, because that is the base of all these algebra things. And I'm going to put a few hash marks to the right and a few equally hash marks to the left. So then I look at 2n plus 1. That just means you're 1 unit from 2n plus 1. So if I go from 2n and I add 1 to it, that hash mark is 2n plus 1. So if you think of 2n being like 0 on a number line, 1 would be 1 to the right. So if 2n is my middle, 2n plus 1 is 1 over. And then 2n plus 2 would be 2 over. Well, that's the same as 2 parentheses n plus 1. Because if you do the distributive property on that, you're going to get 2n plus 2. So that's 2 units to the right. And then 2n minus 1 is going to be 1 backwards. And 2n minus 2 is going to be 2 backwards, which again, that is the same as 2 parentheses n minus 1. So if you kind of understand like number lines and just algebra in general, you can do that without subbing in numbers. And sometimes students sub in 0. You know what I mean? It doesn't matter what you sub in, but either way, you're good to go. All right, 7 is usually the one that nobody likes, okay? So, so let's look at 7. All right, so I have 100 bushels of corn divided by 100 people, men, women, and children. And when I look at this, usually I have 1 or 2 students, you know, that kind of figured this one out. But again, a chart is kind of helpful. So I'm going to make a chart of men, women, and children. Okay, and I'm just going to try to do this. And there's a couple things I have to keep track of. I have to make sure that I have 100 bushels of corn. So that's one thing I have to keep track of. And then I have to make sure that it's divided among 100 people. So my people have to add up to 100, and so do my bushels of corn. All right. So I'm going to force the bushels of corn to work and then see what happens to the people. Because the bushels of corn are the things that have rules attached to them. The people just have to add up to 100. So that's a little simpler. So I'm going to go with the rules. All right. So men get 3 bushels each. All right. Women get 2 bushels each, and children, oh, I said that wrong. I'm going to deal with the 100 people and then do the bushels and see what happens. Sorry about that, because the rules are in terms of 2 bushels per women, and so I kind of want to go that right. So I am going to go with the 100 first. I apologize. So I'm going to do all men, just see what happens. Well, if it's all men, and I have 100 men and 0 women, 0 children, they each get 3. That would be 300 bushels of corn. That's way too many, right? If I have all women, 0, 100, 0 in my chart, and women get 2, that's 200. So it's better to have more women, right? Because men use up a lot of bushels. And what if I have all children? Well, then those are only half each. That's only 50, okay? So it looks like I'm probably not going to have a lot of men because that brings my number up high. I can't have 100 women. That would be impossible. And so I need some children in there. All right, so let's just say I do no men, and I do 50 women and 50 children. What's that going to do to my numbers? Well, women each get what? Women get 2, so if I multiply that by 2, I get 100. And then the children get half, so that would be what? 25. So I'm at 125, which isn't bad because I want to use 100 there. So I think I need to do what? I have too many women because right now I'm going there. And I could maybe add a man or 2 or whatever, but I'm just going to stick with women and children for a while. All right, so say I go with 40 women and 60 kids. Again, these have to add up to 100. And I lowered the women because they get double, and kids I upped because they get half, and we'll see what happens. So women get what? 2 bushels each, that's 80. And then children get 60, which half of that is 30. So I'm still at 110, which is a little high. Okay, so I'm still a little high. All right, so what I want you to do is I want you to keep playing with this, and you need to get this to be 100. Now, there could be some men in the mix. I'm not saying that. So just remember, men use 3 though. Okay, so there might be some answers. There are more than one answer to this. All right. So if you figure out the answer to this before class, what I want you to do is email me the answer and make sure that your people add up to 100. So like these people add up to 100. But then when you do the math for the bushels, these have to add up to 100 too. So like when you give double for the women and half for the kids, or if you do whatever, men get this much and so forth. So make sure your answers for women or men, women, and children add up to 100. And then when you do the bushel thing where men get 3, women get 2, children get a half, make sure those add up to 100. And if you have it figured out, email me the answer tomorrow. I need to get it by before class starts. All right, so like around noon or, you know, let's see, 1 o'clock in that range. And then I will add a point to this problem solving sheet. So, all right, I hope that helps. I hope that gives you enough hint to figure that one out. And again, there's more than one right answer. So just because you found an answer doesn't mean that it's the only one and everyone else has to find the answer you found. There are more than one answers. It looks like this would be a great algebra equation, not so much because you have 3 variables and 2 equations. So if you have like m plus w plus c equals 100, and then you do the whole bushel thing, so men get, so 3m for the men, 2w for the women, and half c equals 100. You have systems of equations, but the problem is if you have 3 variables, you need 3 equations to solve that. And so there's still, even if you did this algebra and tried to do elimination method or substitution, you're still going to end up with more than one variable, which means there's infinite many solutions, or there's going to be for sure more. There's infinite many solutions, but you can't have like half a woman or 0.2 of a male, or so that's why there's really in real life not infinite many solutions. But if you did algebra, it's going to tell you there's infinite many solutions. All right, that's my hint. Email me before noon or 1 tomorrow if you want some extra credit. And some of you might have figured this one out on your own the other day. So I will add a point to this if you email me before noon or 1 o'clock tomorrow with a solution that actually works. So, all right, take care. Again, sorry about class today, but technology is fun sometimes. So we will just keep dealing with it. All right, take care. Bye-bye.